machine learning, data analytics, yes. And then linear algebra, calculus too, yes. I was seeing things like that.
Nice. Let me go to Aaron. Aaron, what motivated you to do this business analytics? Aaron Deborah. Amina, what motivated you to do this course?
Good evening, Prof. So I've always had an interest for mathematics and being able to predict based on numbers to solve a problem. So when I saw that this course involved a lot of ways to find solutions to problems based on statistics and based on mathematics, it always piqued my interest.
What was your undergraduate?
Mathematics.
BSc.
Yes, please.
Where?
Winnipeg, University of Education, Winnipeg.
So your mathematical background is grounded.
Yes, please.
So you are going to scatterbrain us.
Oh no, I just a recap and you learn to unlearn. So basically.
Good. It will help you, but you will also notice that it's not a math that will help you. It is rather your understanding and application of the math.
Yes, please.
Because the businessman does not care about the math.
Yes, please.
All of you are going to realize that it's your interpretation of the statistics and the mathematics to the business manager. That is all that is important. And you see that my line of questions will be along those lines. Anastasia, what motivated you to do this? Anita, what motivated you?
Good evening, Doc. So in my line of business, I think this course will help me greatly, especially with the interpretation of data. So I chose this course to be able to mine my data well and then be able to arrive at very conclusive decisions for the business.
What is your line of work?
I'm a banker and I manage the digital commercialization segment of the bank.
Okay, what do you mine?
So I mine data on our active numbers, utilization, digital utilization, the income we generate from digital usage and all that.
All right. Good. And you, what motivated you to do this? Let me go to Wallace. Wallace, what motivated you?
Hello, good evening, everyone. No, I work with the statistics unit, and at a point I realized we were not making meaning out of our data to help the policymakers to understand what needs to be done and how it should be done. So I approached the university from the statistics unit, and then we made a proposal to the World Bank requesting for courses to be able to work whilst we school to help address the issues at hand with regards to data collection.
You mean the statistics unit of what?
Of Ministry of Food and Agri.
All right, okay. Very good. So why didn't you go to statistics, but business analytics?
I have an IT background. I did computer science. So being in programming, software development, and then working with the statistics unit, we had to now learn the activities of the agricultural side to be able to develop to help them collect data. A lot of data is within the ministry, but it's sitting on desktops.
So my
Means
question
having
is that why didn't you do masters in statistics? Why not do masters in statistics?
basically with the line of grading from the promotional point of view, if I divert to statistics, I have deviated on my grading. So I maintain my line of duties to help the
Okay,
statistics unit.
lovely. Valentina, what was your inspiration?
Okay, sir, I wanted to do something different. I have been in the HR space. I've done my professional certification in HR. And now the HR sector too is venturing more into HR analytics. And so I didn't want to limit myself to just HR analytics, and I wanted to get a whole view, knowledge on analytics in general, not just limited to data HR analytics per se, so that I could maybe venture into other roles in future by not limiting myself. That is why I actually decided to take the course.
Yeah, very good, very good. HR analytics is booming. So let's go to Stella. Coming. What was your motivation? Stop.
Good evening, everyone. So I personally love numbers. I love to work with the computers and everything. So that was my main motivation for trying to join. Yes, please. Yes, please. I just came in with
What was
the
your
first degree.
undergraduate study?
Bachelor of Education in Management at the University of Cape Coast.
So you were using numbers during that period, or your
No,
interest?
it was mostly just business throughout, but it's afterwards that I seem to have developed the interest for the numbers.
Okay. All right.
And looking out for a good course to go. This seemed like one I'd be very interested in. That's why I came into it.
It is one of the interesting ones, to be honest with you. And you guys are going to see it. You're going to enjoy it. And you're going to see that it's more marketable than you can imagine. I have 2 masters in this, and it's more marketable than you can imagine. Okay. And then you will see that it cuts across multiple disciplines. Like one of your friends just said, HR analytics, accounting analytics, analytics for finance, analytics for computers, even computer scientists, analytics for marketing analytics. You know, there are several applications of the engineering analytics. So you're going to see the benefit of this. Beyond the practicality, you're going to see that it's new. And it is where the world is going, because it is encapsulating everything within the world of artificial intelligence as well. So you see good application. Neokai, why are you doing this?
Good evening, sir. My true goal actually is to I found being able to apply data analytics and like recruitment of like players in football. I found it very fascinating, like within the past few years, and it's my goal in life is to work in like the football industry, like when it comes to like recruitment of players, making decisions in the background.
Have you heard of sports science?
Yes, please, I have, sir.
Let me tell you an interesting thing, because what you just said is very interesting. I just came back from London to Leicester just some few hours ago.
Yes,
and
please.
My nephew did masters in sports science. And he showed me his MSc dissertation, which he's completed, finished everything. And when I saw it, In fact, he's actually studying to be a coach. These days in England, they all study, to want to be a footballer or be a coach. It's a whole big thing. And you're right. He applied analytics and he applied, statistics and mathematics in most of his dissertation. So it's an interesting area. Well, as I'm doing the recording, so don't worry yourself, okay? It's an interesting area to do this, and you're going to do very well in it. So are you working in a sports area, sporting industry?
Unfortunately, no. I actually work. I work for the NCA actually. I was working in human resource previously, but then I've been reassigned. I work in administration now, to be precise, fleet and transport management. So I know it's like I've deviated, but then I still have like a long-term goal like I'm working on. So hopefully I'll get there soon.
Yeah. Well, sports is a very big thing. In fact, today he was educating me, even at the lower level, not beyond the Premier League, Champions League, beyond the Premier League Championship, League One, League Two, the National 1, 2, 3. Even at the lower level, it's a big, you have billionaires controlling that industry. And I think that is probably yet to rise up in Africa. But the fact that people are doing masters and you have people who have done PhD in sports science should tell you that it's a wonderful area to delve into. So hold on to it. You might be one of the King Kongs in this area as time goes on.
Amen, sir. Thank you very much.
Yeah, you might. And who knows, if you ever want to do your PhD, that will be a new area to go into. And then you can come back to the department and introduce this whole program there for us.
That would be nice, actually. Sounds good.
Think that way, because it's a big program. It's a whole undergraduate program with about 36 different subjects. Look at that. And then you have a whole master's program with 12 subjects. And you have a whole PhD program, all on sports science. Like, people don't know what goes into the fact that a player kicks a ball. Before the player kicks the ball, the heart rate, the physicality, the physical capacity, the injury list, the hair color, the mindset, you calculate all of these, collect data on all of them. Anyway, let me take two more people, Gloria, and then I'll take Emmanuel Lamte. So Gloria, why are you doing this? Emmanuel Lamte. And you might want to tell, who is a class rep? Class rep, raise your hand.
Anastasia.
Anastasia, you're a class rep.
Yes, please.
Oh, the one I spoke to was not
and
you.
I'm a deputy.
Wallace is the.
Wallace is the deputy. That's why you are doing the recording. Wallace, you don't want me to record. You want to record for them?
Ways can do for us.
Yeah, I always will do it for you, and I'll upload it on the YouTube channel so that you watch it. In fact, I already have the videos on the YouTube channel for last time. They're already there. I'll show you. It's just Dr. K. Remind me to put it on the page for you.
Okay, thank you very much, sir.
So, ladies and gentlemen, I want to just welcome all of you. My name is on the screen. I'm a student. I'm also a teacher. I specialize in artificial intelligence, envelopment analytics, stochastic frontier analytics, economics, and management science. I publish in energy economics, in European Journal of Operational Research. These are the areas I do my annals of operational research. These are the areas that I work more into. I've applied machine learning and envelopment analytics to most of my work. I had mathematics and economics. I enjoy maths. I excelled quite excellently in maths. I've done multiple masters to this area. One is in financial economics. The other is machine learning in MIT and data science. So it's nice to have all of you. I did my PhD in operations research and management science, and the other is in medicine. They're very unrelated. So I don't talk about the medicine one. Okay. Because this one helps me to chop some income. So it's nice to have all of you. Remember to drink deep or taste not the Pierian spring. Bare shallow drought will intoxicate your brain and drinking largely sobers you again. Now, I will be giving you teaching, but I will also give you a lot of things for you to excel in life. So you will notice that I'm not just giving you teaching. I'll teach you how to learn. I'll teach you how to reprogram your mindset. I'll teach you the reason why some consistently do well in life, in everything. Have you heard of the statement that says that there are some people, whatever they touch turns to gold? Have you heard of that thing before?
Yes, sir. Yes, sir.
Yeah. It's not like they are good in maths alone, or they are good at, like, even if you put them in farming, whatever they touch there turns to gold. If you put them in dancing, they touch there, it turns to gold. Why? It is not they themselves, it's their programming. It is their mental operating system. So when you know how your operating system is supposed to work and you harness the mental disequilibrium status from the time you were born, okay, because we have been imbued with a lot of negativities. Forget it. You know, especially when your daddy didn't succeed in that and then he's telling you that, you know. And these things are programmed into our subconscious mind. And we believe that it's not possible. For example, it's possible that one of you does not probably believe that you can get A's in all your subjects. Do you think you'll get A's in every subject? If you believe that, let me see by hand. Do you think you can get A in every subject? No, not that do you think you can. Do you think you will get it? Anastasia, will you get Wallace?
I believe.
Yes, sir.
Strongly.
I
Strongly, or you are guessing?
will.
Yeah. Have that belief, sustain it, because halfway into the semester, you will ask yourself, did I really say that? You know, but your belief must be sustained. And this is critical in success in marriage, success in academic, success in business, success in your job, success in your spirituality. I'm telling you, you have been programmed. Who you are is your nature. What you are becoming is your manifestation. So what you do, if your programming is negative, what you do is that you got to do some 3 steps. One of them is known as hypnotism. Let me just give you some idea. Are you guys aware that children are fearless? If I lock you in a room, okay, a dark room, and then I lock, no, not even in a room. Imagine where you are right now, and you see a lion coming at you. And there is also a 9-month-old child, or even 1-year-old child, with a lion coming at you. Which of you will run? Which of you will run? Is it you or the child, or both of you, or none of you?
The
Rama,
adult,
why?
because we have a sense of fear. I'll put it as our brains are fully developed to see and recognize everything. I think for the children, they don't have a sense of awareness yet. So what should usually make them afraid? It doesn't work on them, for a lack of a better explanation.
For a lack of better explanation, you have a sense of awareness. The child has a sense of awareness. You and I were all created in the image of a creator whose creativity in his creation is creative. You all have a sense of awareness. The only difference between you and the child is that you have been programmed to fear the lion. Research has been done in Texas, California, multiple places across the world where lions have been unleashed and they chase them, the adults who run away, And the children who don't run away, the lions don't do anything to them. Multiple tests have been done. Why do you think that the lion does not attack the child? Because the child didn't run. Fear begets fear. Write it down. Fear begets fear. The same way, if the adult has not been programmed to run away and the adult has stayed, the lion will not attack that lion or that adult. It's been consistently proven. What is fear? Fear is false evidence appearing real. That's fear. So in the mindset, in the programming of the child, that child has not been programmed. Listen to that word. He's not been programmed. If you watch the movie like Tarzan, you will understand. The child has not been programmed to fear the lion. So the only reason why you run away is fear. That's it. Under the circumstances, even if the lion is not going to hurt you, and like I said before, multiple tests have been done. The lion will not hurt. But in fact, the lion chases you and attacks you because you run. That is another thing. There's a book called Elephant, The Gentle Giants of the African Continent. When you read some of this, it will help you. You see, that's why I'm telling you that I will teach you how to learn, how to masturbate your mental gymnastics. It's a very deep word I'm using. It's not the physical masturbation I'm talking about. I'm talking about mental masturbation. How you train the brain to do what you would have wanted to do for you. As a man thinketh, so he is. So I want you to have so much positivity in yourself that anyone with negative mindset doesn't even want to come closer to you. Be so positive that negative people don't want to become your friends. No matter how hard it is, no matter how difficult it gets, no matter how tough the challenge is, tell yourself, I will break you before you break me. Keep that. Yes, you might be working. You might have family. You might have children. You might have a job. You might have a business. And then you have topped it up with a master's degree. Don't use any of these ones as an excuse why you cannot succeed. Tell yourself, I will until. And that positive energy, because remember, you're a vibrational being and you vibrate at your frequency. Right now that I'm talking, some of you are charged mentally because you are hearing positivism and inspiration. And that inspires you to tell, your heart is just out. You tell yourself, this guy is probably talking sense. It's true, I can do it. I teach another course in MPhil. It's known as multivariate data analysis. It's mathematical, very mathematical, but it's applied to business. Okay, one guy got up the first day. He said, Doc, this one I know I'm going to fail. I said, never say that. Then another guy got up. Never say what? Doc, my mother failed. My father failed. You don't like maths. I am telling you, Doc, I know I'm going to fail. And truly, he failed. When I released the results, he came to my office and told me, said, didn't I tell you I'll fail? You see, he was so positive with his energy that he will fail. He could have diverted that same energy that he will pass. And he would be moving in the direction of his most dominant thought. Because you as a man thinker, so he is, you always act in the direction of your most dominant thinking. As a man thinker, so when you think positive, you see positive. When you think negative, you see negative. Because you will act on the basis of that programming, and that your programming will lead to your feeling. Your feeling will lead to your action. Your action will lead to your result. Your result will recycle. So each time you got to look into the mirror and tell that person in there, that replica of you, tell that guy, I will break you before you break me. I do that all the time. When you get out of the bathroom, you tell that person there, I can do it. I will do it. You are not going to stop me. And it doesn't matter how busy you are, you can succeed in each one of them. Sometimes some people say that, how can you do this and do this and do this and do this and do this at the same time? Because you have programmed your mind, you can do it. You check some of the billionaires who are they're doing multiple things at the same time. Okay? Dangote has multiple businesses across the world. They are thinking on this, thinking on this, thinking on that. Why? Why can they do that? Because you have programmed yourself that you're going to succeed. In the same way, if you program yourself that you're not going to succeed, you will not succeed because you will move with that energy. Write this down. The same energy it takes to succeed is the same energy it takes to fail. You got to read the book called The Energy Begins Energy. Are you getting inspired? Are you guys learning? You're not learning. Now let me stop.
Yes, sir.
Yes,
We
sir.
are.
So I want you to have so much positivity that you will finish this whole access and finish your entire MSc. And you'll be so great, so expanded in your memory, okay, and in your imagination that people will look at you and they will be mesmerized. They'll say, wow, Charlie, the kind of knowledge oozing out of your mental equilibrium is too much. That's the sort of person you got to become. You got to be revolutionized, metamorphosized, so that when somebody sees you, that 1 year after the program, the person says, wow, the masters has baptized you. And that is how you got to be. Be so positive that you are going to gain a lot. And you will not let anything stop you. But please, when you wake up every day, don't use the word, When somebody asks you, how are things going? You just watch what I'm telling you today. In the next 3 weeks or 4 weeks, you say that, Doc, you said that the course is getting difficult. Everybody is giving us assignment. This lecturer is giving us assignment. That lecturer says there's an exam. This lecturer says, Doc, this thing is too much. Doc, you said it. Don't worry. From today, remember that will happen. But also remember that you got to pass through your Red Sea to get to your promised land. Remember that you will have to go through the desert until you get to your Canaan. Because storms are necessary to make the oak tree grow deeper roots. Because in order to build a tall building, you need a very deep foundation. When you get time, read the book called The Alchemist by Paulo Coelho. Most academics just read academic books. You got to sometimes read inspirational books, self-development books. They will elevate your mental consciousness to the highest apogee. So along the line, I'll be giving you some of these things too, because mindset is everything, and not just mindset, reprogramming. There's some, for example, the thing that happened in Africa, helicopter, people have connected it to all kinds of jujuism. Meanwhile, that same week, helicopter crashed in America and in other places in Europe. So what is the problem? Why is it that our own alone was connected to juju? Our programming. Okay, footballers will do all kinds of, jujuism at African games. And yet, when they go abroad, that juju doesn't work. Why? Our programming. You see, a person can be in a developing country. That person will not be doing well. The moment the person gets into Europe or America, the person is just the same person. Why? It's a programming, because the person is being reprogrammed. His work ethic, his mental thought, his state, his ability to think, and all of that are being revolutionized. But when that person leaves Europe and comes back to Africa, or after some few years, the person has, bathed himself in the sea of African negativism. So you got to change your mental disposition in anything. Like I said, in anything, and you will do well. Never use, it's not easy. Never use that word. Charlie, it's not easy. Okay? Charlie, never use that. Your subconscious mind doesn't take anything for a joke. If you think negative, you get it. Think positive, you get it. Even if it's hard, anything is hard. Tell yourself, I'm winning. Yeah? I'm winning. Master, I am winning. Okay? When somebody says, I'm going to give you an assignment, you say, bring it on. Say, bring it on. As you do that, your brain is rewired into facing anything that was difficult to be easy. When you are broke, never say I'm broke. Okay. So there are so many things. I'll tell you some of these things along the line. So let's start. Today, I'm just going to do introduction until what you know becomes what you do. You don't know anything. Until what you know helps you and someone else, what you know is useless because the evidence of knowledge is result. That's my statement. You cannot claim to have knowledge if that knowledge is not benefiting someone. And in fact, if that knowledge is not benefiting you yourself, that is why you can have knowledgeable fools. King Solomon said it. You can have someone who is a professor and he is a fool in something. Because knowledge is one thing. Knowledge acquisition is one thing. Applying that knowledge is wisdom. So it's not potential knowledge we are talking about. It is applied knowledge. And applied knowledge is wisdom because wisdom is the ability to see what is obvious, even when it's a secret. That's wisdom. And so when you have knowledge, you should benefit you yourself. Okay? You should be fully benefiting. Okay? So if someone is a professor of marketing, a professor of accounting, he should be benefiting significantly from that professorship. He should be able to generate value for himself and convert that value to other people. He should not be complaining a lot because he has enough knowledge to navigate around the problem because he is a repertoire of knowledge. So whatever you are learning, he should be able to help you and help someone else. Otherwise, according to Molière, you are a knowledgeable fool. Okay? Molière said a learned fool is more a fool than an ignorant fool. So I can be a fool if my knowledge I claim to have acquired is not benefiting me and the people I transfer that knowledge. See, the transfer of wealth is not a transfer of property, cars, houses, and buildings to people. No, it is a transfer of the attitude, the knowledge, the values, the wisdom that created those physical things in the first place. So that even if you are not there, the thing can be recycled. So these are the books that we'll be looking at. Now let's get into the nitty-gritties. What is mathematical statistics? Statistics. David Hahn says that he's a past president of the Royal Statistical Society in Ghana. Okay. He said that the science of uncertainty and the technology of getting information from data, that is statistics. Now watch the word, it's not data. It is the information from the data. It's informed data, not collected data. So you have to collect it. You got to organize, you got to analyze, you got to interpret, you got to present it. It is the information you are pulling from the data. That is what statistics is about. So if you have, a number, how old are you? I am 10 years old. It is irrelevant if you are not going to use that 10 years old to make an informed decision. Oh, if you are 10 years old, you cannot watch this movie. You see the connection. Being 10 years means that you cannot watch this movie at 9 p.m. going. So you are making sense of the number. You're adding meaning to the data. That is statistics. And there are two kinds of them. We have the descriptive statistics and we have the inferential statistics. The descriptives, we shall do it today, where you are describing, summarizing, using tables, visuals, quantitative techniques. That is descriptive statistics. Yeah. Now, where can you apply some of these statistics? Where can you see it being applied? One area where you can apply statistics is in stock market. Anything, see, there are kind of 6 markets, financial markets, or basically 6 markets in the world. Write this down, it's not in the slides here. The first market is the goods market. It takes a very long time to break through in the goods market. Every person is a salesperson. Just keep that in mind, by the way. The goods market. That is where most of the current billionaires, not all of them, that's where they are. So Elon Musk is in the goods market. He's creating, cars, physical goods. Dangote is creating cement. He's creating sugar, physical goods. And then Amazon is doing his own thing, physical goods. Goods market. It takes a long time to break through. And the risk is your mind. Then there's another market known as the money market. The money market. Now, that's the market where you deal a lot with interest rates. And then you know that you get this kind of interest rate. Its association is with the bond market. Okay. So again, whatever is happening in the money market, it translates into the bond market, whether in the physical bond, whether in the treasury market of the bond market, or you go even into mutual or equity funds. But the next one is the stock market. You see, at this stage, you are increasing your risk profiling, and then you are also increasing your return. Stock market is a market that many people have gained and has created incredible returns for some people. From the stock market, the next level of market is the currency market, or what is known as the forex market. That's where you use money to buy money. Those who are good at it, they also do well. It's generating, 2.3 trillions of dollars. And then from that market, you go to the next market. Who can tell me the next market, the last market? Let me see. If you know, you know. If you don't know, you don't know. You see, I'll teach you analytics for finance at the master's level, so I know some of these things. Who can tell me the next market, the sixth market? Looking at the volatility that we are increasing. Are there bankers here? The lady who says she's a banker, are you still a banker? Where's the lady who says she's a banker?
No, is it a commodities market?
Oh, that's the goods market. It's the most volatile market of all markets. The one I'm looking for. It's the highest volatility. It's got a highest Sharpe ratio. And also the lowest of it. That is a market that is known as the crypto market. Very, very illegal and very, very legal at the same time. Okay. So these are the sort of markets that you have there. Now, when you have statistics, you are able to understand these markets. So when you have statistics, it helps you to expand. Okay, I have a friend in Sweden, and he studies this stock market so well. Anyway, so that's it. Life sciences, you can use a lot, especially in the health sector. In fact, most of you in the health sector are going to benefit a lot from this course. Anything health, from dentistry to, to skin, to radiography, ophthalmology, gynecology, family practice, GP, general practitioner, nursing, all kinds of dentistry, all kinds of health situations. Statistics is going to help you. And this course in particular is going to help you. Data science. The weather. You see a lot of forecasting in the weather. Retail, insurance, education, all of these. But before you can understand statistics very well, you got to know some basic terminologies. The first one is the population. And the second one is the sample. Who can tell me the difference between the population and the sample? There's a very simple difference between the two. Who can tell me? Otherwise, I'm going to call everyone alphabetically or mix. So let me start. Valentina.
No.
What is the difference between population and the sample? Valentina. And I'll give you -2, anybody who doesn't talk. Class, you take notes, you write those names for me.
Okay, sir.
Yeah, go ahead.
Population is I would say data collected. So I'll say it's a source of data that has been collected. And then the sample is, I'll say it's a smaller portion of the population. So let's say you have a data that you are working with. A sample is like a part of the data that you have collected.
All right, okay. Let me go to Anastasia. There was a mistake she made in her answer. Did you spot it? What's the difference between population and sample?
So the population is the entire data you want to work with. And then the sample forms a subset of that population, or the data is the sample subset of that data you have.
Okay. What is it that she said that wasn't the right thing about the population? She said something about the population that is not supposed to be said. Wallace, tell me. Wallace Lutrot. You know, sometimes I let all of you show your faces, then I will know those who are really listening.
Yes, sir.
Oh,
I was trying to deduce that I had the same notion with Anastasia, and I went on to think of qualitative and quantitative.
Okay. But it's not about that. It's not qualitative or quantitative. Hanan, please mute yourself. It's not qualitative or quantitative. So a population is not collected, it's there. You don't collect, it's there. It is a sample that is collected. Take note. So a collection of the population is a sample. These are basic things that I'll ask you in test. Now let's go to the next thing. A variable and a population parameter. Okay. A variable is any feature that you can measure. Okay. But a population parameter is a statistic around the feature. We'll look at these ones as we go further. But I wanted to look at an example here. So if you take population is all items of interest. All married drivers over 25 years is a population. All subscribers of Netflix is a population. But that is not the same as a sample, because all subscribers of Netflix is a population. The sample is those Netflix subscribers who rented a comedy. Okay? Not all of them, but those who only chose comedy. So that is a sample of that, all subscribers to Netflix. You should be able to take a statement or give an example of a sample when a population has been given to you. And you should be able to give an example of a population when a sample has been given to you.
Sir, I have a question.
Yeah, go ahead.
So with the first one, the all married drivers over 25 years old. As soon as I saw it, the first thing that came to my mind is, couldn't have the all drivers being the population so that the all married drivers become a sample? Is that also possible? Or it will be defined that this is a population so that you bring out your sample?
Yes.
I hope my question is clear.
The difference is the word all. So once you use the word all, it means that you're going to have part of it. You can easily get part of it. So yes, you can define that all drivers over the age of 25. Okay. And then you can now say that married drivers over the age of 25. out of the all drivers over the age of, it's the all that makes a difference. If you bring all in front of it, then you are not calling it the sample, you're calling it a population. Because you've indicated that it's all. You can just talk about all financial institutions. Okay, all financial institutions, but you have to compare it with banks for you to know that banks are part of the financial institutions. But you can also say all banks, and then you can now say that foreign banks, which now becomes a subset of all banks. So it depends on which one you are defining as all. Please, does that make sense? If it doesn't, say it. So you explain further.
Please.
Sir, it makes sense.
Okay.
It makes sense,
Yes,
right?
please. Sir, please, I have a question related to that. I don't know if I'm deducing correct. Okay. So can it be that a population can then become a sample depending on how you use it and vice versa?
Exactly. Depending on how you use it. Depending on the context in which you define it. You can even take all banks in Ghana, and then you can say all banks in West Africa. Oh, sorry, you can say all banks in West Africa, and then you can now say that sample is banks in Ghana. So in this case, the banks in Ghana is a sample, all banks in West Africa becomes a population. But then when you come to Ghana, you can say all banks in Ghana, that becomes a population. And then you say foreign banks in Ghana, that becomes a sample. I think you get it. If you get it, let me know.
Well noted.
All right, okay.
Yes, sir.
See, these are preliminaries, so we are warming up. Yeah, we are warming up. So this warm up, you should get them. You should get them very, very clear. Now, that is different from data types. You see, data types, there are two kinds of data types, qualitative and quantitative data types. Qualitative and quantitative. Qualitative deals with categories. They use more of text, sound, okay, videos, media, those things, qualitative. Whereas the quantitative, you are dealing with numbers, okay, an exact graph, identifying patterns. The key point is that quantitative analysis looks more at numerical analysis, whereas qualitative analysis looks at textual analysis or sound or videos or media analysis. So anytime you hear of things related to social media, information, you use text for those things. But the umbrella name for all of this is known as the types of data. But that is not the same as what is called the scale of measurement. Okay, so watch this. You want to write this down. Let me just go up and create a white space here. So if at the top here, you have data types. Okay, you have data types. And data types, there are two kinds of data types. You have the categorical, which is a qualitative. Okay, write it down. Then you have the numerical, which is the quantitative. Now, under the categorical, there are two levels of measurement. So what I'm discussing here are called levels or scale of measurement. You have the nominal, and then you have the ordinal. You should learn some of these things on your own. And then under the numerical, you have the interval, and then the ratio. What is the difference? Well, first of all of these on the categorical are nominal and ordinal. They are all letters, English letters. Okay. So for example, when I ask you, what is your name? The answer you're going to provide me is a text. My name is Kweku. That is clearly nominal. But then what is your position in this company? I'm a supervisor. That is ordinal. Okay, but they are all written in English. So what is the difference? The nominal has no ranking in them. You don't need to rank them. So if you ask 6 people, what is your name? And everybody mentions their name, you don't have to. You cannot rank them in order of importance. You can't say Ajwa is better than Kweku, Kweku is better than that. You can't rank them in order of importance. At ordinal, you can rank them. So let me ask you a question. Suppose I talk about information on a Likert scale, and then I talk about types of religion. Which one is nominal and which one is ordinal? Information on a Likert scale. Like
The information on a Likert scale in a way will produce some numerical data, but then the other one will be exclusively text. So
no, you haven't. You haven't gotten what I said. I said information on a Likert scale, okay, and then types of religion. You have to give examples in your head before you go.
Okay, sir. So Likert scale.
What I'm saying here is, please always raise your hand. It helps us not to be in a macula market. Okay. So all I want to know is which one is nominal, which one is ordinal, because trust me, they are all textual. They are all textual. My only thing is that which one is nominal, which one is yes, Irama.
Yeah, so the one to do with a religion is nominal, and then the Likert scale is ordinal.
Why?
Because the Likert scale gives some kind of position. It's in reference to position, but then the one that has to do with religion is not for a lack of it can be what's the word?
I know the word, but I can't tell you.
One does not, should I say, supersede another.
It cannot be
they're all
ranked.
on the yes, that's the word. They can't be ranked. Yes, it can be ranked. But then the Likert scale can be ranked, so it makes that ordinal.
Yep, that's it. That's it. So guys, the word is that you cannot rank it in order of importance. Nominal. Kweku, Kwejo, Kwabena. You can't tell me that Kwejo is better than Kweku. And when you look at the days of the week, Monday, Tuesday, Wednesday, you can't say that this day is better than this day. All of these are examples of nominal. But when you have things like a skill, good, fail, excellent, strongly agree, strongly disagree. You can rank it in order of importance. Or you have a position, assistant lecturer, senior lecturer, professor, associate professor, all of them. You can rank them in order of importance. So the main difference between nominal and ordinal is that even though they are all textual, even though they are all categorical, even though they are all qualitative, one can be ranked in order of importance, the other cannot. How about interval and ratio? All of them are numbers. Okay? Interval and ratio, they are all numbers. What's the difference then? The difference is that interval looks at the gap between two numbers. And ratio looks at just the number, one number. And the good thing about ratio is that it can be zero. It can be zero. So let me give you an example. Suppose I tell you that the weather today, will it be interval or ratio? What do you think? This one is just your thought. The weather, will it be interval or ratio? Will it be interval? Your mindset right now should be able to tell you the right answer. Will it be interval or ratio? Wallace?
Interval, sir.
Why?
We have morning, afternoon, evening, night.
I said weather.
Weather. We have cold and hot.
No, that is not the weather.
Sunny time and then night.
Okay, you've tried. You've tried. Papa Wallace, you have tried. Let's go to another person. Hanan.
It's an interval.
Why?
And because the weather can change at any point in time during the day.
But what
And
do you
so
define as change? Remember, it's numerical, first of all, at the top. So when you're talking, talk numbers for me. I want to say morning, evening, afternoon. Code, we are not using numbers.
so the temperatures,
Okay, okay.
the temperature can change.
But
So
you have
it
still
can
not given me example. You are still not giving me specific numerical example.
maybe between
Okay, let's hand you help. Andrews, help her.
So I would say it's ratio because let's say if the weather now is to 38 point something degrees Celsius, it's a number. It's
All right, so the weather is interval because the weatherman always talks about intervals. You just check. The weather is going to be between 25 degrees and 32 degrees. They never will give one. They always put the numbers in a gap. Okay. It is a range. You see, I just gave you a numerical example. It's going to be between 20 degrees and 30 degrees. That's a number. We don't talk about weather being one thing. We talk about it always. Remember, you are not just picking the number, but you're looking at the general manifestation of the number. Okay. The same way, if somebody says that, for example, okay, let me ask you something. Suppose I ask you, are you going to Accra or Kumasi? Is it nominal, ordinal, interval, or ratio? That question will need an answer. Is the answer you are dealing with? Is it nominal, ordinal, interval, or ratio? Are you going to Accra or Kumasi? Does the answer exhibit nominal, ordinal, interval, or ratio? Hanan?
nominal.
Why?
Because you mentioned the specific place, for example, Kumasi, that you are going to.
Mm-hmm. So why is it not ordinal? Because ordinal too can be a name.
Because it cannot be, the two places cannot be put ranked in terms of importance.
That is what you should have said. That is what makes it nominal. You should say that it is nominal because Accra is not better than Kumasi, and Kumasi is not better than Accra. You can't put it in order of importance. Okay, that is what makes it nominal. Now, suppose somebody comes to you and asks you that, what mark did you get? Or no, say the person tells you that, what grade did you get in statistics for business analytics? And you said that you had 81. And then your friend started laughing at you. And the reason why he started laughing at you, you asked him why, and he said that because he had 98. Why would you laugh at the person? Why would you now, this time, why would you rather laugh at the person for laughing at you? Raise your hand and tell me. Why would you laugh at the person for laughing at you? He said he got 90, you got 81, and he says he got 98. Why would you laugh at the person for laughing at you? You see, I'm taking you guys, your brain level, I'm increasing the mental acuity of your brain. See, at first, you might be saying that I did math, but I'm now making practical use of the math now. Yes, who is ready? Oops.
Is it because the two of you got the same
Who is
grade?
talking? Raise your hand and let me be sure who I'm dealing with. I call, or is my screen? Oh, my screen is frozen.
I was talking about, I think can go on. Thank you, sir.
Okay. Valentina, please go on.
Okay, sir, you would laugh at the person for laughing at you because you all have gotten the same grade, which is an A.
Exactly. So what kind of level of measurement is that? Is it nominal, ordinal, interval, or ratio? Valentina. Is it nominal, ordinal, interval, or ratio?
So please, I'll say it's interval.
Okay. Why?
Because the grade A has a range.
And what is it?
So it's from 80 to 100.
Always complete your answers, and don't let me ask you what you say.
Oh, okay, sir.
80 to 100. Always finish it because that is the answer. That is the right answer.
Yes, sir.
So, guys, you got to know so that interval deals with gaps between the numbers, not just the numbers. Okay. But the key point about ratio is that ratio can be zero. Interval cannot be zero. Ratio can be zero. Ratio can be zero. Ratio can be zero. Ratio can be zero. For example, money can be zero as well as.
So you just said it, so that's it.
Money can be zero. So
Thank you.
money is ratio. If I ask you, how much money do you have on you? Some of you will say 50, 100, 200, 300,000. And another person says, I have nothing on me. That's zero. So the fact that that can be zero makes it what? Ratio. Anything that can be zero makes it ratio. Weight. Okay, let me say age. Age. Is it ratio or interval? This is the trickiest of all I'm giving you. Age. Is it ratio or interval? It's a number. It's a number, but both of them are numerical. Interval and ratio are both numerical. Is age ratio or interval? Which one? Ima?
Well, sir, I think the age is a ratio because it's always a specific number.
It's always what?
A specific number.
Okay. But when you say it's ratio, it means that you agree that it can be zero, isn't it?
Well, yes, if somebody is not born, the person is zero.
Okay. So if the person is not born, is the person a person?
Definitely not.
So, age can't be a ratio because I don't think a human being can have zero age.
Yo. Stella, do you agree with Anastasia?
I actually think it can be both a ratio and an interval.
No, it can't be both. Yeah,
In my head.
it can be both.
It can be both.
Nana Kwame, help them. Don't disappoint me. Is age ratio or interval? Stella, Nana Kwame, Derek.
Yes, sir. So I think age is an interval because we are looking at the gap between the numbers of
So let me just nail it so that we don't strike. Age is ratio. And let me show you under what circumstance can age be zero. You all should know this. If you don't know, it means that you are in China or South Korea. Under what circumstance can age be zero? Who can tell me? There is a circumstance where a person's age is zero, in case you don't know. Tell you. Anan.
On the day of birth.
No, not on the day of birth. Derek.
Always want to play around things because one,
Yes, Saibu.
Sir, I think on the day of death, immediately you are
Did you say death?
when you die?
No,
Death,
not
yes.
dying. Not dying. Not dying. Let's go to Anita. When is age zero? Internet is really big. Gloria.
Yes, sir. I think it's only moments before you are given birth.
So where? When? Where? Sorry, your voice is far away.
So premature.
It's not premature. When you say premature, what is premature? Like somebody has been born.
Sir,
That's before
sir,
you're actually born.
sir, please. I think age is 0 at the point of birth.
Not at the point of birth.
You see, what
So I think during pregnancy.
What you guys have to understand is that
Class, those have made this thing. Mute those who are. Because some people are talking, they are not supposed to be here, and they are talking. So age is 0 when the child, watch the word though, when the child in the womb has not been born. It's still a child. It's still a person. So the moment the child is born, age starts from what? From 2 seconds, 3 seconds, 1 hour. So a child can be 1 hour old, 2 days old, 1 week old, 1 month old, 3 months old, before 1 year old. Do not see 2 seconds old as not age. It's age because it's part of time. But the moment the child is in the womb, if you check the Guinness Book of Records, that's it. The only 2 countries that can disagree with this is China and South Korea. And you should find out why. So age is 0 when a child is in the womb. That's the main thing. That's why age is ratio. Yes, so Wallace, you have a question.
So, sir, can you say it's a ratio the day before birth?
The day before birth. Why is qualifying it as the day before birth?
Because, or hours before birth.
Why are
or seconds?
Why are you using before birth?
Because at that time, it's a human being, but because it has not been born yet, you can't qualify a specific time frame for the unborn
you
child.
attach age to it. That's what you're saying.
Yes, yes, sir.
But Chief of Staff, the fact that you can't attach age to that child is the reason why the age is 0.
Perfect.
The pregnancy is different from the age. The pregnancy is 9 months, but the age of the child is 0. The pregnancy is not for the child. The pregnancy is for the woman. The age is for the child. The 9 months is for the woman. The woman is 9 months old. Okay? The pregnancy of the woman is 9 months. But you can't say that the child is 9 months. Well, all the time when the pregnancy is 9 months, 1 month, 2, the child's age is 0. At the moment the child is born, age starts. The counting of age starts. Let me give you another example for you to appreciate it. Usain Bolt is about to run 100 meters. They started the thing. They say, on your marks, get set. On the dashboard, what number is written at the get set? What number is there?
0, sir.
0. Is it part? It's part, isn't it? That's why it was shown. The moment they do run and the gun goes, now it starts moving. So time can be 0. Time can be 0. So when the clock is 0, 0, 0, 0, 0, 0, column 0, 0, what do you say? It says 12 midnight. I don't know what you say. 12 midnight. 0 is part of time. 0 is part of numbering. What is 0? 0 is the most important nothing of all something. Chorotoho, chorotoho, yeah, chorotoho. 0 is the most important nothing of all something. It's deep. What I just said is deep. You see, you don't value 0, but it's the one you use the most. When you're writing 1,000, what do you do? 500, what do you do? 700, what do you do? 8 million, what do you do? There are more zeros that have been used than any other number on the periodic table. And yet, people don't see 0 as important. 0 is the most important nothing of all something. So it's very important. 0 is part of the age of a child. 0 is part of the height of the child. 0 time is also ratio. So keep all of that in mind. All right, let's move on. I've done a lot of videos on this on my channel, on this categorical with multiple examples. Watch them. You'll appreciate them. Okay, now let's go to notations and some few things. Quick one. Okay. You guys have all heard about the word X bar. Okay, X bar. What is X bar? X bar. Oh. Suppose you have X bar like this. What is that? This is a mathematical symbol. What is this? X bar. Let me go to Amina Brago Asamoah. Amina Brago Asamoah. Have you spoken to the Amina?
No, sir.
Yes, that's why I called you. You should be willing to speak. Because the more you speak, the more I get to know you. The more I get to know you, the good for you. What is X bar? Emmanuel.
So this is
X
the
bar
back.
is
Once is
the
the
mean.
back, whatever it is you pay. So are you trying to tell me that, are you saying
The
that?
mean.
Okay, Emmanuel, looks like you have a very noisy environment. Anita. What is X bar, Anita? Oh, you two made a mistake in raising your hand. Okay, so X bar is the average. How do you calculate the X bar? It is a sum of all the X divided by the sample size. Write it down. It's a sum of all the X divided by the sample size. So the sample size is what we called the data point or the observation. So the sample point is observation. So you can have X1, X2, X3, all the way up to Xn. Okay. It's very important you begin to familiarize yourself with some of these basics. Now, when you sum them, you can put all this summation symbol. This thing is a sigma. Okay, it's sigma. That says sum or the total. So if I put all the x's, and I can do xi here, the way the I can be 1 or 2 or 3. So if I take each one of them and I add them all together, I've gotten the sum. So for example, if you have 2, 4, and then 6, okay, if you sum them, one of the points 2 here is x1, 4 is x2, 6 is x3. When you sum all of them, you're going to get summation of xi. The I here is for the first one, the second one, and the third. You see, when you are summing it as 2 plus 3, 2 plus 4 plus 6 is easier. But I want you to know the symbols, the symbolization, the Greek symbolization for some of these things. So this is something you're going to see a lot of the time, the average. Now, I want you to know that the average is not exactly the same as the mean. Keep that in mind. Write it down. Write it down. Guys, everything I say, write it down. You might not find it useful, but you will need it. Average. Average is a broad term for so many things. For the mean, for the median, okay, for the mode. Okay. So average is not just the mean, just that the mean has become popular representation of the average. That is not really the only thing. Even the mean, you have several of them. You have the arithmetic mean, you have the harmonic mean, you have the geometric mean, even the mean. So these are some of the things you'll be encountering, and it's nice that you begin to. So if you are finding these things difficult, you have to ask, because you're going to be seeing more of these things. Now, I've already mentioned it, but I'm just giving you the umbrella. I told you that we'll look at descriptive statistics. And that is different from inferential statistics. What's the difference? Well, we'll look more at it. Inferential statistics looks at inferences and prediction. Take note. Inferential. Descriptive is going to deal more with the mean, the median, the mode, the minimum, the maximum, the range, the ketosis. the skewness, and all of those things. We are going to take them one by one. Okay. But inflationary statistics is going to be done in 3 weeks' time. But for now, understand the descriptive statistics. So you're going to start by looking more at the descriptive statistics come from the word describe. So we use these things to describe a data set. I'll be showing you a data set pretty soon. So let's start with the first of the descriptive statistics. And that is the measures of central tendency. The measures of central tendency. Okay. The measures of central tendency. They are very, very common. And there are 3. Okay. There are 3 main ones, 3 main measures. The first is the mean, then the median, and then the mode. Okay. I'm taking them before I explain them. The mean, okay, then the median. The median is the top one here, and then the mode. Okay, so what is a mean? They are all measures of center. Okay, you are measuring the center. You are measuring the center. So I want you to consider 10 people who are standing. Okay, 10 people who are standing. Okay, and some of them are taller, some are shorter, some are taller, some are shorter. Okay, but there is a ghost among them, and that ghost is the one whose height everybody will agree with. Everybody, let me give you an example for you to appreciate this. Okay. Suppose you have 2 and you have 6 and you have 9. Okay, let me change the last one. You have 8. Hold on. 2, 6. Let's say 2, 6, and then 2, 6, and then 8. 2, 6, and 4. Yeah, 2, 6, and 4. What is the mean for this? You can tell me the mean. See, I've done something ahead of you in my head before giving you this question. Who can tell me the mean of this? What is the mean value? Ajua Sawa. Ajua Sawa, are you here? Ajua.
Yes, sir.
What is the mean of this?
Please, it will be 4.
To be 4. Are you sure?
Yes.
No. Okay. So the 4, which of these 3 numbers will agree with you a lot?
The last digit, which is the 4.
The 4 will agree with you more than the rest.
Yes.
Okay, good. I agree with you. Now, suppose you have another 3 numbers like this. 2, okay, 6, and then 2, 6, and 14. No. 2, 6, and 16. 16. 2, 6, and 2, 6, and 16. What is the mean? Who can tell me the mean of this? Who can tell me the mean of this? Saibu.
It will be 8.
Saibu. Or your hand wasn't up. Was it Saibu who spoke? Valentina.
Sir. Oh, okay. I think someone is.
Saibu, go ahead. Go ahead. Your hand is up.
Sir, it will be 8, sir.
Okay. So this is 8. Which of these 3 numbers will agree with you the most?
Sir, the 6.
Who will not agree with you at all? Who will not agree with you at all? Anita. It's like some of you raise your hand and you forget that you've raised your hand. Yes, Amina.
The 16.
Why?
So when I compare the difference between the 2 and the 8, and the 8 and the 16, the gap between the 2 and 8 is smaller than the gap between the 8 and 16. Therefore,
Okay.
the 8 is closer to the 2 than the 16.
Okay, so what you guys can see is that the number that we just found, which was the mean, it wasn't part of the numbers. If you look at it, this 8 wasn't part of the numbers. So when you see the three numbers, three data points, the mean might not be part of that. So the mean is the one that is supposed to reflect what they all are looking for. Even though some might not agree, that is the one majority would have to agree. So the mean is the representation, the average of all the numbers. The mean is the center of the numbers. It is a number that everybody sees imaginarily. That is a mean. Later on, you will learn a lot of things about the mean and why it is important and why it's important. But understand that there are three kinds of the mean. We have the arithmetic mean, the geometric mean, and the harmonic mean. Know the differences between all of them. The mean that I just calculated right now is arithmetic mean. That is the one I just calculated, the arithmetic mean. That mean has a problem. The problem with arithmetic mean is that it can have outliers. What does it mean to have an outlier? What is an outlier? Come tell me. Every answer you give must come from your head. What is an outlier? Okay, an outlier is a data point that is not among the whole lot. That is it's an abnormal observation. An outlier is an abnormal observation from the set of observations. An outlier is the one that is deviated significantly from the whole lot. So what it means is that the mean can be misleading if there are outliers in the data. Let me give you an example here. You can have a situation where the means are different. For example, look at these three numbers I gave you. One of them, the mean was what? 4, isn't it? This was the mean, the first one, the first data point. Let's say group A, the mean was 4. Group B, what was the mean? It was 8. Let's assume that for group B, I actually gave you this. Let's assume that I didn't give you what you have, but then instead of this, but let me just write this. Okay. Instead of that, I actually gave you 14. Let's see. Oh, let me see. Let me see. I gave you 40. 40. If I give you 40 for the group B, what will be the mean? You will calculate mean in an exam, so it's very important you can calculate mean quickly on your calculator. What is the mean of the group B? Amina?
16.
16. So guys, watch it. The first one, the mean is 4. The second one, the mean is 16. Do they agree? No. All of them have got the same observation. The sample size is 3. But then the means are different. When you try and find the median in each, the first one, what will be the median? Who can tell me what the median is? What will be the median? Yes, I do.
So to be 6.
What is the
4,
median?
sorry. 4. Sorry.
The median is 4. Eh? That's wrong. Let's go to another person. What is the median? Stella.
Say it will be 6.
6. Okay.
That is the middle number.
Exactly. Yeah. So the median is the middle number. So the median is the middle number. Guys, pay attention. These are very basic. If at this stage you are struggling to know what the mean and median is, it means that you have to put everything aside when you come to class. Turn off every phone and concentrate with your book, because this is critical. The median, you're going to see that very soon. The median is when you arrange everything in an ascending order, you take the middle. So the median is going to be the same, 6, 6. But then if you were to use the mean, it will be different. In fact, this 16, 2 will not agree, 6 will not agree, 40 will not agree. Vanessa.
Yes, I wanted to ask, when finding the median, are you supposed to arrange them in ascending order, like from the least to the highest?
I just said that.
Okay.
Yes,
Okay.
Emmanuel.
From standing back.
Sorry, just
I
following up
said
from what the lady said. In that regard, then the
4
mean
is the
for
mean.
A should have been 4. The median should have been 4.
Yeah, we've already said that the mean for the first one is 4.
No, the lady said 6 and you said that's correct.
Okay. Oh, yeah. It's supposed to be 2, 4, 6. All right. So that is true. I just want to change this number because I needed it to actually get something, to be honest with you. And it's like, interestingly, she probably must have thought that she probably must have realized my mind and gave me what I needed. No, that what she gave was wrong, but that's what. So let's assume that this was 8 rather. Okay. Let's assume that that was 8. In that case, the mean is going to be what? The mean is going to be 16 divided by 3, isn't it? In that case, the mean is going to be 16 divided by 3. And 16 divided by 3 is 5.3. So here, the mean would have been 5.3 for the first one. And then for the second one, the mean would have been 16. But then the median would be the same thing as 6. So the key point is that the median actually measures the center when there are outliers. Okay, so watch it here. Because there are outliers here, because this one is an outlier, this value here even went up to 16. Because 40 is an outlier. An outlier is a number that is far away from the rest of the numbers. And 40 here is an outlier. It's an abnormal observation here. The point I'm just trying to say is that the mean has a problem when there are outliers in your data. Write it down. The mean has a problem when there are outliers in your data. The median is not like that. Now, try and learn these types of means on your own. The geometric mean, the harmonic mean, and the arithmetic mean. Just learn them. I'll give you an example next week on those ones. Okay, so the median. We've already said that the median is when you arrange all of them in an ascending order and you find the center. That's all. That's all the median. Now, what if you are finding the median here? You can tell me. If you were to find the median and you have 2, 4, 6, 9, what would be the median? How do you find the median here? The center will be what?
Say the center will be
He's talking.
4 and 6.
He's talking that I don't see the hand and the person is talking. Who was that?
Says Nanaya.
But Nanaya, we raise hands. You see, people have raised their hands. So when you talk in the air, it doesn't help the others. Stop.
I believe 5.
Why?
Because there are two virtually is even. There are two numbers in the middle. If I'm to look at it, so to get the middle number, add the 4 and the 6, and then divide by the 2.
Very good. So that's how you find a median. Okay. You will find median in some data set I'll give you. So take note. The mode is the most occurring number. Okay. Suppose you have 2, 4, 3, 8, 3, and 9. What is the mode? What is the mode? Vanessa.
3? No, yeah, 3.
The mode is 3. Why?
Because the most occurring number.
All right. So that is a mode. Okay. So these are all measures of central tendency. Keep in mind. Now let's go to deviation from the center. So first we look at centers. So I want you to look at these are trees. Okay, these are trees. These are individual observations. And in this data point, we identify an imaginary center which everybody can arrive at the same time. So the center happens to be somewhere here. That is a center that everyone can reach. But then some of them are far away from the center, far away from the center, far away from the center. So the question now we got to do is that measures of spread is the same as measures of dispersion, right? It's spread is the same as dispersion. And it talks about how far away or how closer the data points are from the center. How far away and how closer the data points are from the center. So let's take an example. So you see, I've realized that if you check this one, let's say that we have another data point here. This data point is so far away from the center. This one is a bit closer to the center. This one is a bit closer. So what you do is that you take each one of them, how far away, the distance each one is from the center. Distance, this one is from the center. Distance, this one is from the center. Distance, this one is from the center. And these distances, you add all and find the mean of the distances. That is a standard deviation. That is a measure of the spread. That is a measure of the dispersion. So the dispersion measures how far away or how close, the close is compact, how close the data point put together are from the center. Now, this is also what you sometimes might call the standard deviation of the variance, but we'll come to that. But I wanted to understand that dispersion looks at how far away or how close you are from the center. There is another statistic you can measure about a data point, and that is range. Range. Range is just the maximum value minus the minimum value. So I want you to look at these numbers. Okay. These numbers. What is the maximum value here? What is the maximum value? What is the maximum value? Anita? Anita. Anita, looks like you don't know how to lower your hands, and you don't know how to unmute yourself. Wallace.
9, sir.
So what is the range, Wallace? What is the range?
2, 3, 4, 6, sir.
The range is 6. Okay. So guys, how did he get a 6? He took the maximum value, which is 9. So he took the maximum value, which is 9. And then he took the minimum value, which is 3. Subtracted the 3 from the 9, and then he got a value of 6. That is called the range.
Hello, sir.
Yes.
I think the minimum value is 2.
Oh, sorry. It's true. Hey, guys. It's serious. Very serious.
Wow.
Okay. So the minimum is 2. So that will give you
7.
7. All right. It's cool. It's cool. It's nice that some of you are really paying attention. Now, my question to you is, if you look at this range, is this so? Would you wish that the range is bigger or smaller? You can tell me. Would you wish that the range is smaller or bigger? For example, right now, this range is 7. Would you wish the range is smaller or bigger? Which one do you think that you would wish it is? Generally, not specifically. Stella.
I would wish it would be smaller.
Why?
Because most of the numbers appearing in the range are smaller than the 7.
Yeah, but why would you wish that the range is smaller? Why would you specifically wish?
It would mean that since I have most of the numbers smaller, it will be closer to the center if it was smaller.
Okay, but there's a reason why it has to be smaller. Practically, why do you wish it's smaller? Anybody? The reason why it has to be smaller is that when it is smaller, it means that much of the data points are closer to each other. That's what it means. For example, suppose all of them, these numbers are all 3. The maximum value will be what? 3. The minimum will be what? 3. And 3 minus 3, 0. Okay, it means that they are all similar. They are all the same. So when the range is smaller, it means that much of your data points are equal or they are similar. And normally, you don't want a big variance. You see, in life, we want equality. We normally want equality so that everybody benefits. That's it. No one person should dominate something, practically. Well, as your hand is up.
Yes, sir. In short, we are trying to avoid outliers.
Exactly. We are trying to avoid outliers. That's it. Get an implication or get implication. Okay. You don't want too much variability in the data set. You want equality. Put it down. You don't want too much variability, but you want equality. But of course, sometimes
Sir, can I ask a question?
You rather want variability. Side.
Hello, sir.
Who is talking? Your hand is not up.
Sir, please, I have a question.
Yeah.
Yes, I'm talking about the outliers. I want to take you back a little bit. The measures of central tendency. You said when there are outliers, it has adverse effects on the distribution. So in that case, median, yes, on the mean, yes. So in that case, median usually works best. That's when you're trying to measure central tendency. So in what situation do we decide to go for the mode instead of using the mean or median? In what situation do we go for the mode to measure our central?
The mode is not usually needed for center. Okay, because the mode is basically it is normally needed when you're looking at the distribution. And we'll come to the distribution. Okay. The mode is not usually the number, the numerical value for the mode is not usually interesting. It is not interesting, to be honest with you, because the mode is just talking about the most occurring number. And so when you get the most occurring number, then what? It is not that useful. It is only useful when you want to look at the distribution. And distribution is not the same as the center. Okay? The distribution is more of not just also the spread, but then is dealing with the peak of the spread. Ooh, that's another one. It's a peak of the spread. It is the concentration. Okay, concentration. So the mode helps you to know where there is concentration or which numbers are dominating. Now, why would you need that? Well, technically, you don't need that. The only thing is that you might need that to indicate. Okay, if you have a data point where it's so large, not like our own that we have here, that is so small. When you have a lot of data, like 50,000, because this whole course is about big data. You come and learn a lot of things about artificial intelligence. And you see that this whole thing, you deal with big data. Look at Netflix. Netflix is dealing with trillions of data every day. People are dealing with trillions and trillions of data. Amazon, billions of data per second. So when you have large kind of data like that, you want to know a particular distribution. You want to know, for example, you want to know which people have watched this movie very, very much. How many people have watched this movie? A lot. So you have this particular movie that are in the top 10. That's how they are able to know that this movie is number one. Number one, because a lot of people are watching the movie. And they use that number one to indicate that a lot of people are watching the movie by taking the mode. The mode. So the mode is more or less the concentration. Okay, where there is that concentration. So the mode is usually needed when you want to know the concentration. Okay. In most cases, you don't want to know the concentration, but in some extenuating circumstances, you want to know the concentration. And if you want to know the concentration, then the mode becomes useful. But if the focus is not to know the concentration, for example, sometimes you want to know where is the concentration of this or that, then the mode becomes useful. Does that answer your question, Wallace?
Say I asked the
Yes, sir.
question.
Yes, sir.
It's answered.
Saibu. Okay, all right.
Saibu.
Good. So that is it. And when there's a need for the use of the mode, you see that. Now, the next descriptive statistic is the interquartile range. Do you remember what the range was? Remember that the range was the maximum value minus the minimum value. Okay. The maximum minus the minimum. Then you get a range. Now we are talking about the interquartile range. Interquartile range. So question is, what, in fact, somebody should tell me, okay, what is the interquartile range? What is the see as the name sounds, interquartile range. Guys, I want you to know that the median is said to be the second quarter. Yes, Neokan.
So this is like maybe the range within a range.
No. I know it. Yeah, you might want to say that for your personal understanding. But what is the interquartile range? Okay, so I want you to write these numbers down in your book. Write them down. I'm going to be mentioning the numbers. Okay. 2, 4, 5, 7, 8, 10, 12, 15, 18. One, 2, 3, 4, 5, 6, 7, 8, 9. What is the median? Who can tell me the median of these numbers? What is the median? I've already arranged them in an ascending order. So you should be able to know the median. Let's go to Stella. Hanan.
8.
The median.
8. Oh, I was not thinking 8. Sorry.
What?
8. Oh, 8, yes.
Who is talking that I haven't called a person? Somebody is used to talking when we haven't called. All right. So the median is 8. Keep that in mind. Now we are going to try and find the maximum value. What is the maximum value? In fact, who can tell me the range? Who can tell me the range? Emmanuel.
The range is 16.
The range is 16. Okay. So let's look at the first quarter. The first quarter. Now, do you guys remember what the median was? Do you remember what the median was? Do you remember the value of the median?
Say it was 8.
Yes, please, 8.
Good, we have circled it. Now, if you want to find the first quartile, what do you do? Remember, the median here is a middle, and the middle is the 50th percentile. Okay, the middle is the 50th percentile, and the middle is what we call the second quartile. So keep that in mind. The middle is the 50th percentile, and that same middle is more or less the second quartile. So what you do is that if you want to know the first quartile, you try and move 25% away leftward from the middle. That is the first quartile. And if you want to find the third quartile, you move 25% away from the middle to the right. And that will give you the third quartile. So that's why I've circled the median for you. So what do you think is going to be the first quartile? Remember, you're moving 25% away. Okay. Now, what I mean is that if you take this middle here, which is an 8, everything to the left here is 50%, and everything to the right here is 50%. Therefore, what would be the 25% left of the median? That is the first quartile. And what would be the 25% right of the median? That is a third quartile. So my question is, what is the third quartile? Sorry, what is the first quartile? The first quartile. You can tell me that one first. Follow. Can be. Aaron.
Sir, it's 2, 4, 5, and 7.
No, I want a number. If you understood me, it is a single number. Let me go to Hanan.
5.
5. That is the correct answer. So 5 is 25%, okay? Because when you move here, it's 1, 2, that is 5, okay? That's 25%. 1, 2, that is another 25%. So on the left here is going to be the 50%. So 5 here is going to be your first quartile. That is how you find the first quartile. Now, what will be the third quartile? How did you calculate the first quartile? That's what I told you, 25%. Okay. Now, if you want to know how to get the first quartile, one simple formula for doing that is this. I mean, you can always find it like that. It's like a position, okay? So if you truly looking for the first quartile, it's like Q1 equals to the sample size plus 1 divided by how many points to the left. Okay, and in this case, how many points to the left was 4. Now, do you realize that the sample size here is how many? Okay, let's find the answer for the third quartile first. The third quartile, let's go to Stella. What is the value of the third quartile?
12.
It's 12. Okay, keep that up. I'm just showing you how we found this 5. For those of you who cannot understand the 25% that I indicated, because the first quartile is the same as the 25th percentile. Keep that. The first quartile is a 25th percentile, and the third quartile is a 75th percentile. Okay. Sometimes, I mean, there's a lot of interpolation here, but when you round it, you get some of those things. Okay, so how did you get that? If you use this formula, what is n in this data set? Why?
N is 9.
So what will be the first quartile position? Because this will give you the position of the first quartile.
So 9 plus 1, that's 10 divided by 4. Huh.
That's 2.5.
No, I'm thinking of how I can locate the 2.5
You start from the
number.
beginning. And of
Okay.
course, you got to interpolate. When you reach two numbers, you just have to take their position. You find the average, that's all. So 2.5 means you start from here. This is going to be 1, isn't it? The next one will be 2.
Uh-huh.
Okay. This one should be 3.
Okay.
But then 2.5 is going to be between 4 and 5, isn't it?
Yeah.
So 2.5 is going to be what? 4.5.
Okay.
Okay. So that is a position. But then 4.5, is it closer to 4 or is closer to 5?
Both.
4.5. Is it closer to 4 or is closer to 5? Remember rounding.
Okay, it's close to
It's
5.
closer to 5.
That's how we got our 5.
Okay.
But let's see how we got our 12. Okay. Use the same approach. So the third quartile is going to be what? I mean, some of them are big. You guys get it. Third quartile. You know the same position. And I move on. I mean, you follow the trend. That is the same trend that you're going to follow. You can do it backwards, or you can do it left up. Because once you take here, okay, you can move backward again, 2.5 from even the center here, okay, which gives you 2.5. So from here, okay, this is 1, this is 2, this is 3, okay. Is it 3? 1, 2, 3. So that is 12 plus 15 by 9, by, what do you call it? By 4. Then you can now use that to find the position. And as you run to you get to the 12 in that regard. And so that is what gave you us the 12. Okay, so you put the 2 together, 12. This is the interquartile range. Is a 12, which is the third quartile, minus the 5. And that means that our interquartile range is going to be what? It's going to be, is it 4? It's 4, right? 8, there you go.
7.
O'Hara, it's 7, exactly. So what does this mean? Let's try to get a sense of it. Looking at this data, what does this 7 mean? It means that the middle 50%, okay, the middle, so if I want to take 50% of this data, forget about the last 2 here, forget about the first 2 here. The middle 50% is going to be these. Let me just use a different color. Okay. The middle 50% is going to be from here all the way up to here. That's the middle 50% of the data set. So the middle 50% of the data set will span a range of 7 units. That's what it means. Okay, so when you find this value, you're going to get 7.
Sir, please, can you come again?
Okay, let me repeat that.
Okay.
The interquartile range value we just found, which is 7, which is 12 minus 5, which is a 75th percentile minus a 25th percentile. When I say 75th percentile, it is this Q3. That is a 75 percentile. And this Q1 is a 25 percentile. The value of the 75th percentile, which is 12, minus the value of the 25th percentile, which is 5, is 7. What does this 7 mean? What it means is that if I take the data set, the middle 50% of the data set, the middle 50% of the data set, okay, the value, the data points, they span a range of 7 units. They span a range of 7 units. That is what it means. Exactly what those 7 units are, we might not necessarily know, but what it means is that they span what do you call it? This span. Yeah, they span that range of the 7 units. If you want, whatever.
Please, can I ask a question?
Yes, go ahead.
So when you say they span a range of 7 units, do you
Look at the
mean
first number. The first number is 5, right?
yes,
The second number is what?
12.
12. That's it. So the range between the numbers are the gap between those numbers. All of those numbers, the interquartile range value is telling you the lowest value and the highest value of that middle 50%. So if I take 50% of the data within the middle 50%, the lowest value of those data points and the highest value of those data points, the gap between them is what? 7 unit gap here. That is what
okay, I get it.
That's what the interquartile range is indicating. So remember, the key point here is that when you have a data point, you should be able to know the first 25% of the data. You should be able to know the first 50% of the data. For example, if you want to know the first 50% of the data, it will rather be here. It will rather be here, not in the middle 50%. And the first 50% of the data is the one I've highlighted. Actually, the 8 is more or less is sitting in the middle there. The same way you can find the last 50% of the data. You can find 75% of the data, the entire 75% of the data set. And that was hanging at 12. You know what that 12 means? That 12 means that the 12 and anything below it make up 75% of the data set. The last two make up that 25%. And if you want only 25% of the data set, we said it is the 5 and everything below the 5. That make up what? The 25% of the data set. The rest are the 75% of it. So you can have portions like pie, portions of the data set. But then the interquartile range is looking more at the middle, the middle 50%. And the middle 50% is made up of 5, 7, 8, 10, 12. 5, 7, 8, 10, 12. These are the middle 50% of the data set. And the bigger value there and the smaller value there have a gap between them of 7. Because the bigger value is 12 and the smaller value is 5. I'm sure you get it. This is the deeper part of what we are doing today. So this is what we mean by range. See, all of these are talking about deviation from the center, away from the center, away from the center, away from the center. They measure deviation. But a proper measure of spread, the proper measure of deviation is a variance. Is a variance. Is a variance. And the variance is very simple. The variance is what you see on your screen. This is a formula for the variance. If you have the data point, and if you want to calculate the variance, all you need first is to find the mean. So watch here. You see that this is the mean. This one here. This X bar, that's the mean. And this one says that take each value minus the mean. Remember here, we found our mean to be, if you could remember, our mean was 8. And so we take every one minus the mean. So the first value was 2. So it will be 2 minus the mean. The next one was, I think, 3. So 3 minus the mean. The next one was 5. So it will be 5 minus the mean. So each one of them minus the mean. Each one of them minus the mean. Each one of them minus the mean. Then you square it. So whatever you get here, 2 minus 8 is negative 6. Negative 6 squared is 36. Okay. And then you go to the next one, and you go to the next one. When you finish, you sum the answers and divide the answer by the sample size. In our work, the sample size was 9. 9 minus the 1 is 8. So when you sum them all, you divide it by 8, and that will give you the variance. What does that mean? Write this down. The variance is the mean of all the deviations from the center. That's the variance. The variance is a mean of all the deviations from the center. It is a spread between the numbers in the data set. Every number. Now, once again, let me ask you, do you want a bigger variance or a smaller variance? You can't control it though, but which one would you want? Do we normally want a bigger variance or smaller variance? Emmanuel?
Smaller variance.
That's it. You're done. Now, the standard deviation is just the square root of that answer. It's just the square root of the variance. Nothing much to know about it, except that normally it's good to use a standard deviation. As the name sounds, it standardizes everything. It standardizes everything. So look at this example at home. Work it at home. Whoever does it should put the answer in the group for me. Compute the arithmetic mean, the geometric mean, the harmonic mean, the median, the mode, the range, the first quartile, third quartile, interquartile range, the variance and standard deviation of this sample data set. Try it, okay? And of course, you see that when you try to look at it, it will be exciting to really look at it. But I have the solution here, so you should check it on your own and then listen. When we meet next time, we're going to look deeply. No, I think it's not yet time, is it? Oh, it's time. It's not time, is it?
No, we have an hour.
Oh, yeah. Okay. That's fine. See, I teach the other groups, so I forgot almost. All right. So let's look at it together. If you can do this, this is like your exam, first part. If you can do this. I wish I had not given you the answers so that I would have checked which one of you would have done it. But then, hey, let's see. The first thing you're going to do, you see, first thing to do is what? Looking at the blue numbers, what is the first thing ideally you should have done? Even before you check anything, what's the first thing to do? Which makes life easier, Anastasia.
So you arrange the numbers from lowest to highest.
Perfect. That's it. Guys, I want you to do that now. Don't check the answers. Do that now in your book. From lowest to highest. From lowest to highest. Do that. And when you're done, raise your hand. Okay, so I see Amina, I see Anita, I see Emmanuel, I see Hanan, I see him. Look, those of you who have not done it, it's important you should demonstrate that you've done it. Because I give marks in class. Just check my thing. You see that I give marks in class. That's why. When I give my distance to my TA to play it back, that's why I'm mentioning names. If you raise your hand and you have not done it, I will ask you something right now. And if you get it wrong, I'll give you -5. So don't raise your hand too haphazardly. Okay, Andrew, tell me your last but 3 number. Tell me your last but 3 number, Andrew.
Third place is 135.
Okay. Lower your hand though. If you know you haven't done it, don't raise your hand. Else if I ask you something, I get to minus 100. And I said that some people are lowering their hands. Okay, so now let's compute let's do the easier ones first. The median. The median. Let's start with the median. Who can tell me the value of, okay, let's do the mean. Let's do the mean first. Let's do the mean. Not the median, the mean. You see, let's do the arithmetic mean, AN. The arithmetic mean. What did you get, Wallace? Wallace, what did you get for your arithmetic mean? I want the numerator and then I want the denominator.
I did the median, which gave me.
Don't worry, we'll come to the median.
The number
come to the
is
median.
the
We
n
will
is
come to
equal
the
to
median.
11.
We
Okay.
will come to the median.
Okay, sir. The mean.
Don't worry, you take your time and do it. Maybe tell him the mean.
130 plus
Asa, stop
135.
talking. Stop talking.
Hey. Divided by
Mavis. Imanalamte. Lower your hand if you're not answering the question.
I'm still calculating them.
Okay, all of you, lower your hand if you're not answering the question. If you're answering the question, keep your hand up. Obri.
Yes, sir. So I got 1,285 over 11.
Okay.
That should give us 116.
You didn't copy it from anywhere.
Please come again.
You didn't copy it from anywhere, right?
Yes, sir. I added them.
Yes, sir means you copied them from anywhere. I'm saying you didn't copy them from anywhere. Is that correct?
Yes, I didn't copy them. I calculated it.
So you don't say, yes, I didn't copy. Once you say yes, it's a copy. It's rather, no, I didn't copy.
All right, sir. No, sir, I didn't copy.
Okay. And what's your final answer?
Please, with that calculator, I got 116.818.
Good. Excellent. You will be told that you should always convert your answer to 2 decimal places. So 2 decimal places, what will be the answer? Still on you.
Okay, please, that will be 116.82.
Correct. That's it. Let's go to the geometric mean. So guys, the arithmetic mean should be 116.82. What about the geomean? Who has calculated the geomean? Hannah.
So I was just about to lower my hand.
All right, okay. Take your time. When you're able to calculate the geometric mean. In fact, if you want the formula for the geomean, I'll show you. The geomean is not simple. Let's see. Look at the geomean. It's not a simple board. Maybe I should guide you. So the first thing you want to do with the geomean, because you have to take the 11th root, which is not simple, but let's still see. So first of all, you're going to take the same way you did the arithmetic mean, you are adding them, isn't it? This time you will multiply them. Okay, you are adding the numbers together. Okay, 75 plus 80 plus 95 plus this, plus you were adding that. This time the same thing, but you have to what? Multiply them. After multiplying them, then you raise it to the power, because that is what the formula is saying here. The formula says that square root means that, note that the square root here is the same as this thing multiplying. This means you are multiplying them. Okay. instead of the square root, you make it to the power 1 over n. To the power 1 over n. So if it is 3, 6, and 4, you multiply 3, 6, 4, and then you raise it to the power 1 over 3 in this example. But in yours, the figures are 11. So it will be raised to the power 1 over 11. Try that geometry, and let me see the smartest one among you all. Emmanuel.
I had 114.08.
114.08. Are you rounding it up or what? What was it before? What was it before?
It was quite a huge figure. So,
Cannot
and
be a
then I
huge
raised
figure. It cannot be a huge. You should be able to get something. Otherwise, you took it somewhere.
I mean, the powers that I did the power raised to the power 1 over 11.
Yeah,
But then
whatever
when I'm multiplying,
you will have to round it up to that number you told me, because that 114.08 will not come onto you. You will have to now deduce from that, from the answer you had.
Okay.
But then the answer is supposed to be 114.08. But before, it's supposed to be 114.0807 before you round it up. Guys, you got to know that your calculator is going to give you 4.2592822272 e plus 2 raised to the power 111. That e plus 2 means that there are 22 zeros, or there are 22 decimals after the 4. So you got to use that approach before you take the 11th root of that number. After taking that 11th root of that number, that is when you get it. Let me just show you here. But that is how you're supposed to attack these things. This is it. You're supposed to attack it in this format. So if under exam condition, that's why I wanted to work it. Because you seeing the answer makes you feel that you know it. You don't. But until you actually start punching your calculator will tell you that, oh, this is wrong, this is wrong, this is true. Then you know, because now you are punching the calculator, you are doing hands-on work, you are doing practical work. That is it. What about the harmonic mean? The next one is the harmonic mean. This is the formula for the harmonic mean. It's very simple. The simple formula for the harmonic mean is that the geometric mean you had, the 114.08, you square that number and divide it by the arithmetic mean you had. Remember that the arithmetic mean you had was 116.82. So you should easily be able to get the harmonic mean. Do that and let me see. Somebody should tell me the value of the harmonic mean. Since we've indicated both the arithmetic mean as well as the geo mean. When you get that, raise your hand. Jessica.
For the harmonic mean, I got 111.41.
Excellent. That's good. That is it. That is how it's supposed to be. 114.40 or 41. Okay. That is how.
111.
Yeah. So that is how you're supposed to attack each one of these questions. Guys, if you don't understand something, say it. Say it. Yes, Wallace. Wallace.
Can you please help with the calculation? I think I got it wrong. So if she
Calculation
can,
of what?
the 114.
Okay. All right. So the value you had for the geo mean was 114.08. Which one are you talking about? Is it a harmonic or the geometric?
The harmonic.
Okay. So first you had this value. You had you see, the harmonic is simply the geo mean square divided by the arithmetic mean. That's it. Now, what is a geo mean? The geo mean is 114.08. You're going to square that divided by the arithmetic mean, which is 116. I think 0.82. 82. So that's it. So first take this 114.08, square it. Square it. And whatever you get, divide by 116.82. Wallace, you should get your answer.
Sure.
Let me know when you have it. Let me know when you're able to have it. You should get what Valentina has just put there. Valentina, that was your final answer, isn't it? For the harmonic.
Yes, sir.
Very good. So let's move on. The next thing now is to find the median. So easily tell me the median. That's the easiest of all. Who can raise a hand and tell me the median? Because you've all arranged it in Mavis, in ascending order. Mavis. Emmanuel Obiri.
Please, the median is 120.
The median is 120. That's the easiest. Okay. Oh, yeah. And what is the mean? Oh, so the mean is what we have already found. Okay. What about the mode? What is the mode? New kind.
So it's also 120 again.
The mode is also 120. Very good. Now, this 120 means that 120 is the one that is occurring the most. Guys, when you go and draw the distribution, let me show you some secrets. When you go and draw the distribution, this is how the normal distribution looks like. When you go and draw the distribution, the top of the distribution will be that 120. The 120 will be the value of the distribution. So where this one is showing the distribution, okay, then these are actually sales. Then the sales that is at the peak is the 120. Okay. Remember that the arithmetic mean is 116. That is not equal to 120. So the arithmetic mean is below the median. So we can't say that this data set is normally distributed. It's not normally distributed. Okay. Now, let's go to the next thing, the range. To be able to get the range, you need to know the maximum value as well as the minimum value. Who can raise their hand and tell me the value of the range? Self-calculated, self-calculated, not copied from anyone. Who can tell me the value of the range? Danaya. Uhara.
85.
How did you get that?
So the highest is 160 and the lowest is 75.
Very
So you
good.
said, yeah.
So that's it. 85 is a range. Okay. Now this range is big. Okay. So that means that there is some sort of variability. It's a first step to knowing the variation in the data set. Okay. Now let's calculate the first quartile. Q1. Do you remember how we calculate the first quartile? Now the first quartile is finding the median of the numbers below the median. Okay. So first of all, what was the median? Let's go here. Okay. If you had arranged them like this, okay, this is it. So the first quartile is going to be the median of the numbers below that 120. You see here, the 120 median. Find the median of those numbers below that 120, and that gives you the first quartile. The median of 75, 80, 95, 110, 120. What is the median of them? That is going to give you the first quartile. That's another easier way of calculating it. What is that? Stella.
95.
It is 95. Now, what about the third quartile? The third quartile. What is the median of the numbers above the median? The median of the numbers above the median. That will give you the third quartile. What value is that? If you don't know, lower your hands. Before I call you and you say that I made a mistake. Valentina.
135.
135 is the right answer. Who can give me the value of the interquartile range? Interquartile range. The value of the interquartile range. Emmanuel Lamte.
I think it's 30.
That is not correct. Who can give me the value of the interquartile range? Amina.
40, sir.
40. How did you get it?
The third quartile minus the first quartile, which is 135 minus 95.
Perfect. Excellent.
Correct.
That is how you're supposed to find it. Guys, if you are here and so far you are not doing something, the forces in your house are too much. Now, finally, okay, we are going to look at what is known as, not even finally. We're going to look at the variance because that's what the question was saying. Let's go back to the question. Question says that you should find the variance. Okay. Look at it, the variance, and finally the standard deviation. Now, Naya, is your hand still up? The variance and the standard deviation. So let's find the variance. How do you get a variance? Check the formula for the variance. There you go. So the variance formula is take each number minus the mean. Take each number minus the mean. So the mean was 116.82. Okay. In fact, this will take a bit of time, so I wouldn't want to delay you. I'll just show you. But you have to take each number minus the mean. So when you take the first number is 75, it will be 75 minus the mean. Okay. And then you square it. 80 minus the mean, which is 120, is square it. And 95 minus the mean is square it, like that. So if you do that, you're going to get something like this. 120 minus the mean, you square it. 95 minus the mean, you square it. 110 minus the mean, you square it. 80 minus the mean, you square it. You square, all of them. And then when you're done, you divide it by the sample size, n minus 1. That's the variance. So what is the top part? The most important thing is the top part. So remember, you are subtracting and then squaring. You're subtracting and squaring. You're going to get 6,563.6364. And then as for the 11 minus 1, you get 10. You do the division, and the variance is 656. So that's the mean of the dispersion. That's the variance. Or the mean of the deviation from the center. Now the variance here is good, but the standard deviation is even better. Okay, this value here, and I'm going to tell you something very important. The standard deviation is just the square root of this variance. So if you take the square root of the 656, you'll get 25.62. This is the standard deviation. Now, do you remember the value of the mean? The value of the mean was 116.82. The value of the standard deviation is 25.62. Is that good or bad? The answer is good. Write it down. Is that good or bad? The answer is good. What does this mean? Now write this down. When the mean is greater than the standard deviation, it means that the observation points are similar. The data points are similar. They're not the same, but the values of the data points are similar. But when the standard deviation, and you do this thing in your artificial intelligence.
Please, can you come again?
Okay, let me write it here. When the mean is greater than the standard deviation, the data points, okay, the observation, they are similar to each other. So you see that some of them were 75, some of them were 120, some of them were 80, some of them were 85, 90. Okay. These numbers, the standard deviation is telling you, the fact that the mean here is bigger than the standard deviation means that the gap between these numbers are not too much. We don't have too many of them that are too big. Neither would we have many of them that are too small. They are all similar numbers. Similar. They are not too deviated from each other. They are not too deviated. This is the practicality. You know, sometimes when you have 50,000, you can't even go through them to see, say, some of them are bigger than others. But just looking at the standard deviation and the mean can tell you a whole story. Now, the opposite is true. Anastasia.
Doc, please, I want to find out the variance, the calculation for the variance. Is there any other formula? I'm looking at a question where the numbers, like we have lots of numbers. Are we supposed to do this one just as you shown, or there is another formula for it?
Now you can show me if you have.
No, please, I don't.
That's the formula you have, Mamia. Embrace it. In real life, you will not have to do manual calculation. But in this test, you do manual calculation because that is it. You are only learning what is behind the scenes. You will do manual calculation like this. Yeah, maybe the figures you are going to be getting are not going to be too big. But this is it. If you have another one, you can show, but this is what I know. Do you remember my inspirational speech I gave you when we started? Anytime you feel something is hard, what should you say? Who can remember what I said? Anytime you feel something is hard, what should you say? Bring it on. That's what you should say. So when you raise your hand, I thought you're going to say that, Doc, bring it on. You are ready. Whatever will come, bring it. Change your mind that way, and I'm telling you, nothing will look difficult for you. Even if it is, you feel you can still do it. Even if it is. So who can tell me the opposite of this statement we have made? What does this statement mean on the opposite side? What does it mean if the standard deviation is bigger than the mean? What does it mean? If the standard deviation is bigger than the mean, it means that there's a lot of variation among the data sets. It means that some of the values are too big and some of the values are too small. That's what it means. Finish. So take note of that. There is also a coefficient
Please, is that the... Hello, sir.
Yes.
Please, with the last statement you just made, is that also the same as there being outliers in terms of the reverse being true?
No.
When you said that when the mean is greater than the standard deviation,
No.
it means the data points are similar. Okay. Can you please explain that a bit for me? Because I think I'm getting it mixed up.
If the data point the standard deviation is bigger than the mean, what it means is that, for example, you can just take your calculator. I could have used Excel to show you, but if you have a standard deviation, which is bigger than the mean, that is not good. That is not good. It simply means that there are some numbers that are too big and there are some numbers that are, it doesn't necessarily mean that they are outliers, but they have kind of separated themselves. Because we don't even know the center. It's like the center, the center is when a majority, when a particular few have separated themselves from the majority. But this one, they are kind of misclassified to the extent that so many are small and so many are big. So it's like there's no center. Now, let me ask you something that you better understand it. If the standard deviation is 0, what does it mean? If the standard deviation is 0, what does it mean? Who can tell me? If you can tell me this, it means you have understood everything today. If the standard deviation is 0, what does it mean regarding the data point?
So does that mean that there's no...
Are you asking me or you are telling me?
Okay, I'm telling you in confidence. Does that mean that there's no variation? No, it means there's no variation.
You are still asking
No, I'm saying that.
What does that mean?
No, I'm saying that there's no variation.
What do you mean by there's no variation? Be specific there.
There's no. They are not. They are, the data points are similar to each other.
That's the word Samuel Boache has put there beautifully. It means that every number is the same. That's it. All the values are the same. So if the 11 values you have 3, they are all 3. Every data point is 3. I want you to understand from that perspective. So if they are all the same, that's when the standard deviation is 0. which means that it is when some are getting bigger than others, that is when the standard deviation begins to what? Increase. So the standard deviation being 0 means there's perfect, number for each one. They all have the same number. I'm sure you get it. Sometimes, yes, Saibu.
Sir, but in data collection, if you have your standard deviation to be 0, is it a good thing?
I'm not saying it's bad or it's good. It depends on what your objective is. If your objective is that you want this variation, you get variation. If the objective is that, but it hardly will happen in real life where the standard deviation is what, 0.
Okay.
Unless in robotic engineering. Even that. You can't have that because I don't know, why did you start in the first place? There's some, like you go and take, let's say you go and take the profit of every bank and all the profits are the same value. In real life, no way. Operating Kafa, do you get me? Yes, Wallace.
I want to get a more understanding. In short, if there's no data collection issue.
What do you define as no data collection issue?
There's no more practice of the data collection, which is impossible in Ghana.
It's still impossible anyway. There's always something.
Yeah. So data collection can never be. It can never be 0.
The word perfection is not even there. Do you know that? Do you know that the word perfect, they're a perfect couple? Do you ever have a perfect couple?
Not that I know, sir.
Do we have perfect economy?
No, sir.
Do you have perfect score usually? It doesn't usually happen. So generally, things are not perfect in life. Even twins are not. So that number where I said that the standard deviation is 0 is not possible because it's not possible that all the numbers will be 120, 120, 120, 120, 120. That's the only time the standard deviation will be 0. But it was just to let you know that if that was so, then the standard deviation will be 0. That's all I was saying. I'm not saying that it should happen. There will always be some disparity, but we don't want too much disparity. Wallace, do you get it?
Yes, sir. Yes, sir.
Yes, sir. I think the reason why he was asking about the good and bad was that in the first instance, he said this is good because the mean is greater than the standard deviation, meaning that the data points are similar. So for that being said, does it mean that when it is the opposite, it means that it is bad?
Yes. And then
Okay.
when I said when it is the opposite, I didn't also mean that when it is 0. Okay.
Okay.
Not even
Okay.
0. 0 is the opposite of, is the extreme version of the good, isn't it?
Okay.
When it is opposite, where the standard deviation is bigger than the mean, that is not good. For example, let's take a banking industry. And then you have some of them having so big assets. And some of them have got so small assets. When I say asset, I'm talking about, asset, total asset of the company. Some of them are in billions. Some of them are not. Let's take a Premier League. Some of the Premier League, clubs, they are very rich, very stinkingly rich, like Man City and Chelsea and Dems. They are very, very rich. And then you have other people who are competing with them, but they are not that rich. So there's a lot of disparity. So even if these rich ones continue to win, these other ones who are not winning can always say, oh, but you guys are rich. That's why. That word, these guys are very rich and we guys are very poor. That is huge standard deviation above the mean. The same thing, go to economies in Africa. If you are in the UK, for example, yes, there are some people that are very rich and there are some people that are very not rich. But people are not all that poor, generally speaking. the disparity is not too much generally. But in African country, one person alone can rule the whole country. People like just about some 20 people are stinkingly rich. That means that there's a lot of disparity, which means the standard deviation is way above the mean, the average. In other words, some people are too stinkingly rich and others are too stinkingly poor. So this can happen in real life. It can happen. That is why I use the word what? The word that it is bad. It is bad, but you can't control it. Yours is to just let the data talk. You are just indicating that, oh, I saw that when you look at the banks, I saw that some of the banks are mega banks. And some are also very, very small banks. And I think that that is not fair because there's always preaching of fairness and equity all around the world. So if there must be fairness and equity, it doesn't mean that there must be perfect equity, but I mean, there must be fairness and equity, because everybody is working, generally speaking. So that is what I meant by, it should give you a clue. Anytime the standard deviation is bigger than the mean, it should quickly signal to you that no. Something is exhibiting variability. There's a lot of variation in the data point. And if there is, then you have a story, because now you have a story and advice to give to managers. Suppose you are doing this and you spotted that this is what is happening in the banking industry. You can talk to the regulator of the bank. Take the central bank, the boss of the central bank. Look, there's too much. So let's do this. I know that you have the same minimum capital requirement for all banks, okay, especially all banks that are domestic. And you have another minimum capital requirement for foreign banks. Why don't you, even among the domestic, increase the capital requirement for the two big ones and reduce the capital requirement for the two small ones so that we balance? Or sometimes there's measures and acquisition. So the two big banks will go and acquire the two small banks. And then they will put their assets and liabilities and workers together, rename themselves. Now we have a new, emergence of a new company, sort of. So there are so many policies that will come out of this just from this standard deviation being bigger than the mean alone. So that's what I wanted to think. Okay. You can also have the coefficient of variation. It is another means of the dispersion. But the only thing about the coefficient of variation is that it's useful when you are looking at very highly volatile markets. Very highly volatile market, like when you are dealing with stocks, where the standard deviation represents sort of a risk, the financial risk, and then the mean represents sort of the return. Okay, so instead of using the standard deviation, you rather decide to use the coefficient of variation. It's simply the standard deviation divided by the mean. And it gives you a better way of looking at the thing. It gives you a relative measure of risk return trade-off. But that's something that for those of you who will be doing analytics for finance, you look into. The last two are skewness and ketosis. Skewness and ketosis. I want you to go and read about these two on your own. I think last year that's the same thing I said. I said they should go and read it on their own. Skewness and ketosis. These two are also measures of dispersion, or better still, measures of distribution, distributional measures. They measure lack of symmetries. Skewness looks, see, one thing about skewness is that it looks at lack of symmetry. Symmetry means normal distribution, normally distributed. Normally distribution is where the mean is the same as the median is the same as the mode. As you can see the graph here. And when you look at this, the negatively sloped, the tail is at the bottom on the left. The positively sloped, the tail is at the bottom on the right. The skewness simply looks at the tail. It means that majority of the data point is not in the center, but it's also on the far left or far right. That is it. It's not in the center. In the center is normal. That is the skewness. And get the difference between the skewness and the ketosis, because the ketosis doesn't look at just the how do you put it? The spread. Ketosis looks at the thickness, the top part. The top part. So at the very top, you have the mode. But whether the mode is teeny, let me give you an example of what I mean. Okay. So when you have this, it means that the data is normally distributed, because when you look at this, the left part and the right part are similar. And when you have these, okay, it means that the data is left skewed because the bottom is left. When you have that, okay, then you have this. Okay, the data is right skewed because the right part is flat. Okay, now we finish with that. Let's come to the top. The top now. When you look at the top, it's very, very flat. You can have a very pointed top. You can also have something like this, okay? But at the top, it becomes flat and it comes down. So whether that is very pointed or very flat, that's a peakiness. Can be very narrow or flat. Very narrow or flat. That is what we mean by the ketosis. What do they mean? The skewness and ketosis. Just try and understand these two. Normally, like once again, you will not usually consistently be using this, but on some few occasions, very risky, situations, you need skewness to be able to do that. Ladies and gentlemen, what a start. What a start. That brings us to the end of the entire tableau.